Okay, today we're going to be looking at the normal distribution. So the normal distribution is a statistical distribution when the mean, median, and the mode are all equal. So the mean, median, and mode are all equal. And you can see it is what we call a bell-shaped curve. So you've probably heard that before. So I can call it the normal curve or a bell-shaped curve. Okay, and it's used really widely in business. It's a good way of looking at natural phenomenon. So it's used a lot in any sort of statistical analysis. So what I've done here is I've shown you the heights of a large sample of adults that I represented as a frequency histogram. So can you imagine if this was all drawn up as a little frequency histogram? Here they are. Okay. The more data we get, the closer we get to what we call the normal curve. So this data you could see, if I could put a curve over the top of it, it's becoming a normal curve. Okay, so many natural characteristics such as, and I've put here, height, blood pressure, and skull width are normally distributed. Now, a small aside, if I look at the spread of a normal distribution, it usually depends, or it always does, I shouldn't say usually, it depends on the standard deviation. So the lower the standard deviation, the more clustered the scores will be around the mean. And we've seen that before. Okay, so here we have my mean, which is in the middle, and I've got most of my scores. If I was imagine me drawing everything on here, if I could draw a histogram on here, they're all really clustered around the mean. Okay, and so that means we've got a very small standard deviation. So our standard deviation is very small. So now if we look at this diagram here, you can see my results are quite spread out. So that means my standard deviation must be quite large. And so the standard deviation is just telling us how far away from the mean we are. And we can look at that also in terms of our normal distribution. So here I have, and hopefully you've printed one off, and this is from the New Century textbook. This is what we call the empirical rule for a normal distribution. So if I think about a normal distribution, if I think about the entire curve, so everything underneath this curve, so here it is here, I'm going to think about that being 100%. Everything under the curve is 100%. And what we break this up into is we break it up into standard deviation places. So here we are one standard deviation away. Now, this textbook was written before we had a change from NESA. We're now saying standard deviation is represented by this letter mu. So one standard deviation above, 34% of the population live there. And one standard deviation below, 34% of the population is there. And so if I have the standard deviation, one standard deviation below here, 13% live in this part below it, and 13% live, 13.5% live in this part above or between the first standard deviation and the second standard deviation. And then so too, 2.35% live here and in here, so between the second and third standard deviations away from the mean. And then this tiny little part is 0.15%. Okay, so if we look at the bottom of that, it's putting it together and saying 68% of the population, of any population we measure, lives between one standard deviation below and one standard deviation above the mean. 95% of the population that we have is represented in two standard deviations below and two standard deviations above the mean. And if we take three standard deviations above and below the mean, 99.7% of the population will lie somewhere in there. And then we've just got this tiny 0.15% that live above or below that normal distribution. So how does this look like mathematically? So let's have a look at some of these examples. The first one says the height of a large group of adults is normally distributed with a mean of 170 and a standard deviation of 8. So when I get a question like this, the first thing as I do is I draw my normal curve. And because I saw that word normally distributed, that makes me think I must draw a curve. The next thing I do is I put in my mean, which was 170. Now the next thing I'm going to work out all of those standard deviation places. So 170 plus 8 gives me 178. So this is one standard deviation. Between 170 and 178 is one standard deviation. And then if I add on 8 to 178, I'm going to get 186. And if I add on 8 again, I get 194. And then I do the same to below. So if I do 170, because remember 170 was my mean, and if I subtract 8, I get 162. If I subtract another 8, I get 154. And if I subtract another 8, I get 146. Now we're asked to see what percentage of heights lies between 162 and 178. So between 162 and 178, that is one standard deviation below and above. So if I went back to my empirical curve, you could see that that is 68%. I can just read that off the curve. So what percentage of scores? It is 68%. Now, having a look at what percentage of heights are more than 178? So more than 178 is this area here, here, and here. And we can go back to our curve. So we're looking above one standard deviation. So above one standard deviation is that 13.5, the 2.35, and the 0.15. So I'm just going to add those three numbers together. So I have 13.5%, and the 2.35%, and the 0.15%. And altogether I get 16%. Now another way we could have done this is we could have thought about the whole curve being 100%, and I could have subtracted off that 68%. So that would have given me above and below, one standard deviation and everything above that, and one standard deviation, everything below that. And then I could divide that answer by 2 because I'm only wanting this half, and I'm using the fact that my normal curve is symmetrical. So if I do that, I get exactly the same answer, which is 16%. So you can use either method. So it might be a good idea now to pause the video and see if you can do part B yourself. So now we're going to combine the percentages, and we now have a number of adults that are living under this normal curve. So it says if a random sample contains 6,000 adults, how many have a height between 146 and 194? So 146 is here and 194 is here. So if we think about it, we've got one standard deviation, two standard deviations. We're looking at three standard deviations above and below. So we can go back up to my chart. For three standard deviations, that is 99.7. So I have 99.7. Now that's a percentage, so I'm going to write it over 100. And we're going to multiply that by 6,000 to see how many adults. So if I do that, the answer I get is 5,982. So within three standard deviations, 5,982 people lie there. Have a go at doing part 2. Pause the video, see if you can do it yourselves. So between 162 and 186. Well, here is 162, so that's one standard deviation below, And 186 is right up here with 2 standard deviations above. So 1 standard deviation below is 34%, and we're going 2 up. So we need the 34% and the 34% and the 13.5%. So first of all, I'm going to work out those percentages. So I've got 34% and 34% and 13.5%. And all up, I get 81.5%. So now I need to work it out. So I know I have 81.5. I'm putting that over 100, and I'm going to multiply that by the 6,000 adults that I have. And when I do this, I get 4,890. So 4,890 people lie between 162 and 186. Thanks for watching.